You know, 50 years ago, the supersonic industry was really in the prime of its development. Soviet Union started with their first airplane, had its first flight, and then shortly thereafter the Concorde. And as Blake also mentioned, you know, in terms of the technology, at least the Concorde really showed that it was technology was able to do supersonic flight. Unfortunately, you know, those rising fuel costs and environmental concerns and the downturn in the global aviation economy after 9/11 led to the airplane being taken out of service in 2003. Now here we are 50 years later, and we've got a resurgence in supersonic air travel before us, and Blake was certainly getting us, I think, all excited about that. Certainly I was. And again, these technological improvements that we've had in the last 50 years, whether it's in materials or computing, is really going to make a difference. But some of the challenges that we had 50 years ago are probably still there today in terms of noise standards, emission standards, and maybe even some political pressures from regulators, both here in the United States and in other countries. So I'm going to join the panel now because we've got a great panel today to talk about some of these issues and a few others associated with it. So I'll start off with just a few introductions. First to my immediate left here is Captain Joe DePete. He serves as the 11th president of the Airline Pilots Association International. And they represent more than 61,000 professional airline pilots in the United States and Canada. And it's the largest non-governmental aviation safety organization in the world. He's also the chief spokesman for the union, advancing airline pilots' views both before U.S. Congress and the Canadian Parliament, other government agencies, airline and other business executives, and of course the news media. Joe's based in Memphis, Tennessee, as a pilot for FedEx Express, flying the A310, the 300, graduate of St. John's University with a BA in political science, and has served as a captain in the Marine Corps. Sitting next to Joe is Mr. Eli Dorado, who's the head of global policy and communications for Boom Supersonic, where he leads Boom's work both domestically and globally regarding policy matters and leads their public communications policy. Prior to joining Boom, he's got a really great background, by the way. He and I talked a couple months ago, but he was a senior research fellow at George Mason University, focusing on such areas, not just aviation, but cryptocurrency, internet governance, intellectual property, and cybersecurity. He has a PhD in economics, served at the Bureau of Economic Analysis, and was part of the legislative staff for Representative Wally Herger from California. Chris Rocheleau, another old friend, good to see him here today, is the Executive Director for International Affairs at the FAA, and he's responsible for developing international policy and providing guidance across the various disciplines of the FAA. Mr. Rocheleau oversees the FAA's liaison offices around the world, works closely with his international counterparts, including national and regional aviation organizations, as well as the agency's direct involvement up at ICAO. Prior to this appointment, Mr. Rocheleau was the chief of staff for the FAA, the whole agency, and has been with the agency for over 18 years. And Nancy Young at the end, there is the Vice President of Environmental Affairs for the Airlines for America, or A4A. It's a position she's held since 2007. She's an environmental attorney, and she directs A4A's environmental sustainability programs, represents the A4A Airlines in international negotiations regarding aircraft noise and emission standards, and provides counsel on other environmental issues of significance. Nancy's done a lot of work with the Commercial Aviation Alternative Fuels Initiative, which is working to hasten the development of commercially viable, environmentally preferred alternative jet fuels. In addition, she participates in the working groups under ICAO's Committees on Aviation and Environmental Protection and serves on the board of the Air Transport Action Group, or ATAG. So, welcome.
Thank you.
So I'm going to start with Eli. There's a follow-up to Blake's presentation. One thing I'd like to ask is, why is supersonic travel making a comeback from Boom's perspective?
So why? Well, first of all, thank you for having us here. It's a pleasure to be with you all. So why is it happening? I think it's sort of pent up innovative energy. I think we've had, and this gets back to amplify Blake's point about why we're doing this. It's, we haven't had a speed up in transportation in my lifetime, right? And to me, that's the real reason to do this. It's to make the world a better place. It's not about, there are a lot of adrenaline junkies out there. There are a lot of people who care about going fast, who want a fast car just to go every once in a while. For me, this is about the world-changing quality of being able to go faster and expanding that capability to everyone. And we haven't had that speed up in our lifetime. And Blake was talking a little bit about the second order effects of what this will do for the world. And to me, the reason I'm excited to work on this, and the reason I think that it's starting to get momentum, is people are starting to think about, wow, that is a really powerful vision. And this is actually, to my mind, this is just as a very personal thing, the most highly leveraged way I can think of to make the world a better place, right? Is to enable this speed up that we haven't had since the dawn of the jet age, and think about all the second order effects that will cause. So I think there's a huge pent up demand for people who are starting to realize that this is possible, and this will be a huge positive benefit for the world.
And Nancy, do you see the airlines, getting excited about this too, at least domestically, or what do you think's going on in the back of the executive's mind at some of our airlines?
Sure. I mean, there's certainly a lot of interest in what's going on there. I think everybody knows that airlines are about innovation. We're about connecting people, the types of things that Eli and Blake have spoken about. And so I think there's a lot of thinking about what the business model may do over time. And I think that's good. I think there's also, and I know we'll get into that on this panel, we have to put it within a context of the way that we do business. So things that we'll get into more and have already been touched on, where it fits within our sustainability goals, where it fits within the expectations that we bring environmentally friendly products to bear. Issues like that I think will be critical. And also one of the questioners asked something I think will be very significant. Where does it fit within the ability to manage the airspace in a way that serves all people? And if you look at it from an airline perspective, we're very keen to continue to make that airspace very efficient with what we operate today. And so something like integrating supersonic aircraft would be a major aspect of our planning for the future. So I know we're going to get into those types of things. So I think we see a lot of opportunity. We also see the challenges, and maybe I'll hint that sometimes optimists, when you see a challenge, also see the opportunity within the challenge. And I think that's what we're focused on.
Eli, I want to come back to you with a question. There's other folks that are getting involved with this technology. You're not the only ones.
Sure.
You've got the Boeing Ariane partnership going on. You got Spike out there doing this as well as yourselves. The three of you seem to be taking a little bit different approach, though, on how you're approaching the market and the size of the airplane and so on. Any comments you want to share in terms of your approach versus those of the other guys?
I mean, look, I think that the market is plenty big for everyone, right? I mean, if people are going to really travel that much, as much more as Blake said, and I believe they will, then there's room for a number of supersonic airframers and different approaches. That said, I can tell you why we're doing the approach that we're doing.
Yeah.
Okay. So the commercial market is just massively bigger than the business jet market, right? And like Blake said, there's 500 routes globally that this works on, just the transoceanic route, not even counting, where we're going to get to, which is overland supersonic. And with that, 1,000 to 2,000 airplane demand, that in itself is just much bigger than the entire business jet market that we see for supersonics going forward. The other thing is, when you decide to go commercial, that forces you into another choice, which is what speed are you targeting? So we're looking at Mach 2.2, and we think for airlines, it really has to be Mach 2 plus to make it work, especially across the Atlantic. So right now, a New York to London flight is about 7 hours. Most people typically fly that as a red eye coming from the US. If you were targeting something like Mach 1.4, like some of the business jet companies are doing, you're talking about turning that 7-hour flight into a 5-hour flight, which is still long enough that you probably want to fly that as an overnight flight, but it's just a really bad overnight flight because you don't actually get to sleep, and you get there and you're really, really groggy. So by going Mach 2 plus, you turn that overnight flight into a daytime flight, and all of a sudden it's significantly more attractive to passengers. And so that raises another issue, which is that if you look at a Mach 2.2 design and a Mach 1.4 design, those are as different from each other as the Mach 1.4 is from today's Mach 0.8 or 0.85, right? So the proportional difference. So they're really different technologies. The amount of speed difference between them is so large that it changes a lot about what you have to do with the airplane, including things like we have to use variable geometry inlets, whereas someone doing a Mach 1.4 airplane can do a fixed inlet. So it increases the complexity, but it also increases the opportunity by a significant margin.
Good. Chris, so why is the return to supersonic travel a priority for this administration?
Well, first of all, thanks for having me this morning. When you think about the question in its totality, the administration and the Department of Transportation have made it very clear that they're interested in embracing and enabling innovation in the transportation sector. Certainly at the FAA, we recognize that innovation is more or less the hallmark of the aviation sector, and so we want to be part of that. When we think about companies like Boom, like Boeing, and some of the others that are out there investing the time, treasure, and talent into bringing this to life, I can tell you that the FAA wants to be part of that, and the government wants to be part of that. I mean, you look at NASA and what they're investing in this effort as well. And so the FAA, for a number of years now, we've gone to a more performance-based approach to certifying and enabling some of these aircraft technologies. So at the end of the day, when we hear speeches or presentations like Boom, and we talk to the people who are looking at piloting or certifying the aircraft and things like that, we don't want to be the long pole in the tent. We want to be part of the journey in getting these aircraft and enabling travel, the global travel for customers and obviously people in a safe manner. So the administration will continue to kind of endorse and support, and the FAA, through a number, both domestically and internationally, will be working to kind of make sure that we're part of that effort.
Great, thanks. Joe, one of the questions to Blake, kind of something I wanted to follow up with you on in terms of how you integrate some of these new kind of airplanes into the existing environment that we have today. So from an airline pilot's perspective, what challenges do you see in terms of integrating, say, supersonic flight in with the other subsonic flights?
First of all, good morning, everybody, and thank you, Terry, for having us. And just one quick aside, because Terry was an ALPA member for many, many years, an executive air safety chairman, which is a very big deal in the association. Safety is our highest priority. We represent 62,000 pilots at 33 airlines in the United States and Canada. And we always talk about you, Terry, because your timing and your instincts are just always so right on. We always make a joke that we'd rather be, lucky than good, even though that's not true, right? We're all good. But the thing is, we always make fun because Terry, had this great career at ALPA, and then he moved over to a fantastic company like Boeing, and he had a wonderful career there. And then look at you here, running RTCA, and boy, did you time that departure out of Boeing correctly, because that's, I'm a stock and option trader that deals with probabilities and timing, okay? this man's got it. So if past performance is any indication
I had
of
no
future
inside
result,
I had no inside
the
information.
RTCA is in great hands right now. So, but thank you for having me today. No, I mean, when you look around us, the airspace is just there's so many new entrants as well as existing entrants that have, just increased capabilities now. The association's really big into commercial space right now. In fact, we're facilitating a dialogue, as you know, Nancy, between commercial aviation and commercial space to work together, as well as with UAS. I just spoke to Uber Elevate. So it really comes down to this. Can we here in the United States, a great country that we are, and I love what I'm seeing coming out of the administration in terms of innovation, we really do need to keep up with the infrastructure, right? We've got a fairly congested airspace here in the United States. And then when you're talking about what you're getting ready to do, Eli, the necessity for the ICAO involvement, right, of being able to have a framework to support this kind of technology. So we're at the Airline Pilots Association. Look, sign me up. I am so excited. That airplane looks, Overture is just such a beautiful aircraft. It's a gorgeous aircraft. I'm all about, all pilots are about higher and faster. Of course, safety being the primary thing. And I want to, may I? I just want to read one thing, and it's just something to sort of keep in mind. And I say this to everybody that I talk to. I talk to CEOs all over the place. And it's not so much with you guys, because it's really a lot of the technology and the basis for what you're doing here and the understanding about, aggressive data collection and things like that and the benefits that can bring in terms of safety. But here's something that Dan Elwell said the other day at the ComStack meeting, and he said, and this is where we live as pilots, right? Here's what he said. He said, safety, it bears repeating. If safety is not the hinge on which your company turns, you will not survive. The safest businesses in the long run are the most profitable. When you cut corners, you're actually cutting profits. It might not catch up with you right away, but make no mistake, it will, and it'll do so in spectacular fashion, right? So the benefit you have over, I believe, over these other entrants that I mentioned, like about untested unmanned aerial systems or commercial space now, where we're dealing at 10 to the minus 9 in terms of risk reduction, and they're maybe 10 to the minus 6. All I see is if we can invest in the infrastructure and the procedures that are necessary, the operational procedures that are necessary to integrate you in, I think, it's there. So, thanks.
So Eli, you've heard kind of maybe some of the priorities Nancy was talking about, and Chris, and now Joe. Can the supersonic manufacturers address those priorities?
Yes, absolutely. Thank you for the softball question. So, I mean, on safety, I completely agree that safety is the #1 priority. And we've been engaged with FAA's certification office since my second day on the job, actually, over 2 years ago. And so, they're actually contributing resources, already this early in the program. We're not entering service until, as Blake said, the mid-2020s, but we've had ACO resources working with us on making sure that we're designing in compliance and taking safety as the first priority, even this early in the design program, and integrating into the airspace is of course so important, and fitting into the global policy environment, as everyone has said, is extremely important. I've spent a lot of time in the last 2 years in Montreal working with the KO to make sure that we can be a globally globally recognized and fit into the global system for regulation.
Well, thanks for that lead into the next question, which I was going to ask Nancy, in terms of your work up at ICAO and working some of these noise and emission standards. What's been your experience in the context of supersonic?
Thanks for that. And I think it is a really critical thing that everybody's touched on as a foundation of going forward with supersonics, having the international standards. So I don't know how many in the audience know that you must know originally there were noise and emission standards for supersonics that applied to the Concorde. And where we are today, the noise standards are essentially sunset. And so there are no international ICAO standards for supersonic aircraft, either for landing and takeoff, or for sonic boom cruise conditions. And it's interesting too, because that sort of is mirrored in the United States. So you have to think about it on two levels. You need international standards, and then to be able to operate domestically, you need those to be mirrored domestically, or you need a variation on them if your country decides to do something different. So ICAO has been working on scoping the noise standards for the last several years, and the manufacturers, Boom among them, Boeing, others, Gulfstream on the business jet side, others have been providing data, and you have certification authorities like the United States, and whether it's France, United States, the Chinese, et cetera, participating as experts in that process. The process, some will say, is very slow. Some of us who've been working on noise and emission standards for a long time say that it's very ambitious, the timeline. What was agreed in February of this year actually was a work plan to develop basically the technical background on the noise standards, so that there would be a basis for going to a standard position. Like between now and 2022, the real work has to be done on the technology side, the economic side, the environmental side, et cetera, within ICAO to answer how do you do noise standards. And then we expect the timeline would allow from 2022 to 2025 to actually develop those standards and agree on those in the ICAO context. Similarly, on the emission side, there actually still are international emissions standards that are in place. The question will be for ICAO, and they've answered it actually since 2007 multiple times. The experts there have said they're outdated. And so ICAO's environmental group, in particular the emissions group, has a scoping exercise itself to go through those. I think the real challenge there is going to not necessarily be updating those standards, but a carbon dioxide certification standard for future aircraft was decided for subsonic aircraft in 2016, and there is no such standard for supersonics. And obviously, with climate change being such a significant focus, there will be a question about how do you do a CO2 standard for a supersonic aircraft? Do you factor in the speed? Do you factor in that in terms of kind of the allowance of the carbon dioxide and fuel burn, et cetera? So I think there are novel questions that are going to be presented. From an airline perspective, we want it to be done right. And I think, in talking to all the manufacturers, they do too. We don't want any corners to be cut, and we actually want to be careful about the precedent set for supersonics, because frankly, our business continues to be subsonic aircraft. And you don't want to set precedents on the environmental side that will really endanger that. The United States has a more aggressive timeline, and Chris will probably speak to that. With Congress's support and the administration's support, there's a directive for the U.S. to work on these standards quicker, and that could better inform the ICAO process. But from an airline perspective, we think it's critical that you have the international standards.
So, Chris, kind of the same question in terms of your work at ICAO and working with other regulators around the world. How do the U.S. timelines and the work you're doing up at ICAO, how are those things all fitting together, and what challenges do you see?
Yeah, I mean, so, and Nancy laid it out very nicely. I mean, we're very involved at ICAO in making sure we're informing the conversation on what we're looking to accomplish through whether it's the Committee on Aviation Environmental Protection and some of these other work groups. I mean, the 3-year plan for them to go through and start setting these standards, we hope, in addition to our domestic work, will kind of advance where we want to go, whether it's in 2025 or beyond. The other reference is, so back in October, they passed the FAA reauthorization. In that authorization, it directed the FAA to kind of show leadership in this area. And we have 2 rulemakings that were mandated to us to enable or to go forward on. The first one being the landing and takeoff standards for these aircraft. And so we've got a March of 2020 deadline on that, and we've already started work along those lines. And then we look at kind of the second piece to this, which is equally important, and that is to enable to basically clarify and streamline the process by which these developers, these manufacturers are able to go out and test these aircraft. And so we're working through that, and we're on schedule to get those done, that notice of proposed rulemaking done this year. So there's definitely some domestic activity that we will hope will inform what we're doing up at ICAO. We're very involved at the Air Navigation Conference last year. We raised the issue of supersonic and our support and our hope that we will work together with other countries to get this done. And then, of course, in addition to kind of that work, the focus here and domestically and making sure that we can take that data. I mean, we're talking about data-informed decisions, right? That's what we're looking to do. And so the work here will inform the work at ICAO, and we will hope to kind of influence, convince, cajole the audience up there as well. So.
And you mentioned you do work up at ICAO as well. Do you work with any other individual regulators? And we always talk about London to New York. So are you engaged with directly with the European regulators, for example, or is everything pretty much done through ICAO?
A lot of it's done through ICAO. We, of course, are engaging with other regulators, including Europeans at EASA. Mm-hmm. But yeah, I mean, the ICAO process is incredibly important. And actually, people are often surprised to hear me agree with Nancy that I don't want any corners cut on this. I want this to be a data-driven standard, because I think we really recognize that how important that is. And our message to ICAO and CAPE specifically is let's do this business as usual. We'll bring data forward. We will, and let's keep the standard practice, which is, don't assume any magical technology. Don't kill the business case by making the standards too stringent, but make sure that there's a real environmental benefit there. And those are the principles that we support, certainly in the ICAO context, but also in the domestic context. And we want the standard to be data driven. We do think we can do it, faster than maybe some people at ICAO think we can do it. But absolutely, without cutting any corners, this process needs to continue.
And Joe, through the International Federation of Airline Pilots Association, IFALP, up in Montreal, how are they approaching this work with supersonic travel, and any insights you can share with us on that?
Yeah, absolutely. So the association, we're the largest member association in the International Federation of Airline Pilots Association. That's our emulating ICAO structure, basically an organization. Think of it as the UN of pilot organizations around the world. And we most recently came together in Berlin, and we've been actually working on these in commercial space and many UAS and many different things. But I think, Nancy, you said it well. I think there needs to, we've begun work, and the association has communicated the need for standards and recommended practices to help facilitate this new technology safely to integrate it into the system. I mentioned earlier, it's all data-driven stuff, and when you think about it, what we've achieved here in the United States through that methodology. If you remember back in 97, not to go off here a little bit, but back in 1997, after a series of pretty serious accidents, the commercial air safety team was formed by the FAA, and then through a program called the SIAS, the Aviation Safety Information Analysis and Sharing Program, we began a huge data collection effort where we switched from a forensic approach towards accident investigation to a proactive risk model, which is fantastic. And then, as that evolved, after a series of 4 other accidents, culminating with Colgan, if you recall, we pilots, we took a look at ourselves as well. We said, are we trained well? Are we accounting for the amount of flight time that we have and given certain values for that? And so we closed the circle, and now when you look at it, I mean, here in the United States, I think through the help of the FAA, working together with industry and the regulators, we have not, since 2009, we have moved over 2/3 of the world's population in small composite tubes, or large metal tubes, in the lower stratosphere without a fatality. The only one fatality most recently, and I don't mean to say only as to not think it's serious, because it is, but it was the fan blade, right, from Southwest. So, but that's a record. I think I don't think that's matched in human history when you consider what we're doing as well. And I think this is the next step. If we ever we're going to have a chance to ask questions too, I think, because I just had one competitive question that I wanted to ask both Blake and Eli too, that relates to suborbital flight. So, curious.
Go for it.
You want me to?
Yeah,
Sure.
Well, I wanted to see, hey Blake and Eli, do you see, because like I said, I'm so familiar with the commercial space efforts right now. Do you see what you're doing as complementary to what's going on there? Where does it fit in that kind of from a business?
Sure. So I would say, look, the mission of our company is to eliminate the barriers to experiencing the planet. Right. So we want to do that as effectively as possible, and that's time, money, and hassle. So anything that removes the barriers to experiencing the planet, we support. Right. In terms of the suborbital business model specifically, it would be fantastic if it worked. But just listen to the conversation that we've already had here today. What are the landing and takeoff noise standards for suborbital flight? And Blake talked a lot about the economics. What kind of load factors do you think you can get on a suborbital flight? To me, those are huge challenges. And then if you think about our technology rule that Blake talked about, we're doing no new technology, and that's for a very thoughtful reason, which is it's hard to get a whole bunch of new technology certified and innovate on the business model at the same time. Sure. So we hope it works. But we also think that we're focusing on the right area for us, right. and it could totally be the case that Boom is working on Mach 2.2 flight today, and 20 years from now or 30 years from now, we want to work on suborbital because that's the most effective way to eliminate the barriers to experiencing the planet. And we'll see if we get there, but we think we're doing the right thing to advance our own mission.
Okay. Thanks.
I want to pause before we go on to see if there's any questions from the audience based on what you've heard so far, either from Blake's presentation or from the panelists so far.
So I'm curious if anyone would be willing to weigh in on some of the safety issues that were associated with Concorde. So we've talked about the economics and the fact that ultimately that's what doomed Concorde out of the market. But those of us with some background in system safety recognize there were some fundamental problems with that airframe in the fact that it landed faster than any other airplane. It didn't have flaps. Because of the narrow fuselage, it had high energy if it did throw a tire. When we actually lost one in France, there were 19 precursor events to that where engines were damaged due to tire debris. So I'm curious whether or not there are safety issues that, in particular, Boom is looking at beyond just the economics and the impact on the environment, and whether you can comment on that.
Sure, I can take a stab at that. So Joe asked me. Joe asked me. We were sitting back there, and he's like, "How fast is this thing gonna go on approach?" And the answer isn't finalized yet, but I would say we're looking at something like around 160 knots, so not that out of the scope of what a subsonic aircraft could do. And of course, we've had. Hopefully we've had innovation in tires as well over the last 50 years. We will have flaps, like we. So we are. I think that it's going to be a significantly safer airplane than Concorde was, and of course we also benefit from. The accumulation of experience in certification over the last 50 years. Concorde could not be certified today, right? If it was certified to modern Part 25 rules, it would fail. So this is going to be as safe as anything else that's in the sky, because regulators will make us do it, and we agree that that's the right business model.
Yeah, if I could jump in real quick. So certainly the standards today are different, and we will be working closely with the manufacturers as they develop these, using the data that they're generating. But I also think it's important to pick up on what Joe mentioned, and that is the safety network, the system that's out there today to share information, not just the data from the manufacturers, but also from the operators and the other folks that are involved in this aviation community, quite honestly. That informs what we do. So the precursors today would have been caught way before 19 or whatever the number was. So I think the system itself today will enable that in conjunction with the kind of the good work being done by the manufacturers themselves.
Yeah, and I'll just add too, the amount of data we get off of airplanes today is tremendous. I don't know how much data came off of the Concorde to be looking at things and looking at some of those precursors. I'm assuming not much compared to the thousands of parameters that we pull off of today's modern fleet. So being able to take that data and really analyze it well and look for those precursors before they become an issue is going to be very important. So, anything to add, Joe? If you
What they said, it is, no, I'll just wrap it up, I guess. It's night and day to where we were, to where we are today. And, today's framework, and like you mentioned, in terms of the FOCA data and the data coming off the airplanes, you look at the Airbus A350 now, that thing's talking, I can't think of how many parameters are coming off that airplane right now. But, and that's what leads us to that risk predictive model that I was talking about. It's just fascinating. I got a demonstration of it at MITRE one time, and where you'd have like maybe one benign risk factor here and one benign risk factor here and one here, and they're all benign, but the magic of the algorithm knows from experience is that when these things connect in certain ways, they become bad things. And it's just such a incredible, and that's why, like folks here, let's talk about the elephant in the room here for a second. Can't have shutdowns anymore. We can't have government shutdowns in the aviation industry. It's just so counterintuitive. Because at the time and the moment when we needed to be able to see into that risk model, to see emerging threats, and Lord knows if you've got, I'm going to wave my labor hat for a second. I got my pitch here, but because obviously I care about the dignity of work. You had distractions are the worst thing you could have in aviation. We had air traffic controllers that weren't being paid, making a Sophie's choice whether to sleep in the car or pay tolls. This is what year is this? What industry is this? This is so foolish. And so that's the part that's missing. But the good thing is that the administration sent some good signals. I mean, the FAA Reauthorization Act 2018 is a fantastic piece of legislation. It's facilitated the FAA to have that dialogue with ICAO and to move this forward. The thing is, we just can't get in our own way. We sit from a government perspective, we end up tripping over our own feet because everybody in this room's invested in success and safety. So.
Any other questions?
My 2 cents.
Yeah, the new engine technologies that are being foreseen that will enable better emissions performance for a supersonic engine, and also CO2 and noise, for LTO noise, let's say.
Are you asking relative to Concorde or in the future?
For boom.
For boom, what are the technologies? So I mean, it's all kinds of things. So it's better combustors, better compressor aerodynamics, better materials inside the engine, especially in the hot sections. Ceramic matrix composites that can withstand much higher temperatures. We have, amazingly, Concorde. I am always blown away by the fact that they were able to do a variable geometry inlet designed on paper, because that's really hard, and we're going to have a even more efficient variable geometry inlet. We're going to have a variable nozzle system on the aircraft. So it's the propulsion system is significantly better. And as Blake alluded to, once the supply base starts investing in supersonic specific technologies for engines, then it starts to get really exciting when you get things like variable cycle. I saw a NASA paper on non-metallic engines, right? And you can imagine 3D printed non-metallic engines. So we're building off of a lot of innovation, and there's a lot more to come, I think.
So Nancy, let me ask you this. You touched on it a little bit in the beginning, but what does it take for to really make the business case for supersonic travel from an airline's perspective?
Yeah, when I started my remarks, I was talking about optimism and pessimism, and I'm going to put this in terms of challenges, and you can look at it either ways. First, we've talked a lot about the environmental side, but what we haven't given you is the context for that, which is on the noise side and the emission side. On the noise side, we've reduced the number of people exposed to significant levels of aircraft noise in the United States by 94%, since 1975, while more than quadrupling enplanements. That's an incredible story. And yet, we're probably at, again, an all-time high in terms of noise complaints and challenges and differences in people's expectations about what they will experience relative to aircraft noise. And we are committed, and we have a great greenhouse gas emissions records. In fact, again, we're 2% of the nation's greenhouse gas emissions. We drive 5% of the GDP. We've improved our fuel efficiency 125% since 1978. Saving 4.6 billion metric tons of carbon dioxide. You can go on and on with very good statistics showing why we're a green engine of the economy. So you've got that, and then you get the questions about a supersonic jet, whether the noise will be tolerable. The technologies have evolved quite a bit, as Eli and Blake have said. But will that be enough? And where will it come out at the end of the day? We don't have the aircraft yet. So where will it come out in the end of the day on the noise side? And is that something that's going to fit into what the airlines think is right in terms of sustainability in their portfolio? And also on the climate change side, you have seen, whether it's really mainly in Europe, but it's expanding, this question of the flying shame movement, where people are saying they just won't fly because it's so bad. And I think a lot of that is borne by misunderstanding, but this perception and reputation issue is very big. And I think the supersonics will play in that. To get more to what you may have really been asking on the business case, there's a real question, I think, about it in terms of what is our incumbent business as airlines. And if you think about it, and I did look into it a little bit to make sure I had my facts right, a significant portion of airlines' revenue really comes from premium passengers. And those premium passengers are on the same aircraft that the economy passengers on. And you could argue, depending on the way you look at it, in a way, the premium passengers are subsidizing, in a way, the ability for people to fly to London in an economy seat. An example that I would have is a Heathrow, let's just take Dulles to Heathrow. Almost 2/3 of the revenue on that really comes from business class and premium economy. And yet you have this whole aircraft. And so will airlines be interested in a business jet only type of application when they have such a significant fleet of these airlines that meet the needs of different price-sensitive passengers? And you can look at JFK to LAX if we get across over the country, and the first class and premium economy passengers in that are about almost 50% of the revenue on those flights as well. So it's not just the international side. So I think it'll be a question about how the business evolves, and does it evolve, and whether airlines are able or willing to subject a portion of their business as if it's only that business class, and what will that do to our incumbent fleet, essentially. And I think that again, you can look at it as a challenge, and there may be opportunities in that challenge.
Yeah, good. Thank you. I'd like to just spend a few minutes talking about what are the next steps. So Chris, from a regulator's perspective, what do you see as the next steps to make supersonic travel a reality?
So I think we talked a little bit earlier about the rulemaking projects that we're working on. We'll be working on the clarity and the streamlining on how to get the aircraft tested. We'll work on that, which will happen this year. We're looking at next year for the second rule, which is essentially outlining the landing and takeoff standards. Our work at ICAO will continue. I mean, just listening to kind of the conversation here this morning, there are questions, there are concerns, there's perhaps even some resistance. And so in our role as both the regulator, whether it's working on operational feasibility or certification standards, those kinds of things, we've got to be able to have that conversation, and we can't let kind of anecdotes and the bad things of the past, if you will, inform or complicate our way forward. So we'll be doing, whether it's the rulemakings or our engagement at ICAO, to kind of inform good decision making, whether it's through CAPE or other venues, to allow for this innovation to continue. Now, whether there's a business case, I mean, you know, the FAA will pull out of that conversation, but in terms of enabling this technology to move forward, that's what we're going to continue to do.
Okay. And Joe, you've been involved with some of the other new entrant conversation going on, whether it's UASs, commercial space. What is kind of your thoughts on what next steps should be based on what you're seeing from the other new entrants in the community?
I think, you know, given the safety stuff and the stuff that Chris just mentioned, you know, I sat on the Next Gen Advisory Committee subcommittee, and hopefully on the NAC when they finally get that going again. In fact, we'll be here tomorrow for the DAC, actually. I'll be sitting on the same stage probably, or we're actually in discussion. But I think the main thing is I noticed that from an infrastructure challenging situation, you know, the amount of congestion we already have in our airspace here, to be able to accommodate, you know, this new capability. I remember at one point we were dealing with some VNAV issues on parallel approaches, and there was an effort to try to increase throughput. Right now, the current requirement is to have two glide slope, basically, you know, guidance to the ground, basically, on both of those. And in an effort to increase throughput on closely spaced parallel approaches, they wanted to regress and go back to a more non-precision approach on one of them, which increases workload, reduces safety, is contrary to what FAA tried to do, but way back in 2000. And really, the reason is because of the different equipage levels that are there. So I'm assuming that, obviously, this is going to be a very well-equipped airplane, but it still has to factor in. And so what's the lowest common denominator out there? I think we really need to invest and think about what we want this national airspace to look like, and particularly focus on airports to keep that through, because there's nothing more frustrating than to, you know, arrive, you know, takes a while to get in the flow of traffic, and then to get on the ground and you're waiting 20 minutes for a gate. I'd say, just to segue on that other, because I will weigh on to the business side, even though my primary focus is all safety, right, and everything like that. But it seems to me like if the airlines did hop on here at some point and offer a premium service of some sort, together with their bread and butter, that could increase the revenue per seat mile and help defray some of the initial costs as you launch in. My 2 cents, but
sure.
Blake would know better.
And I'll just add a little bit there. I mean, we've talked to a bunch of airlines. You know, I think we have like 30 active conversations with airlines at the moment, and every single airline that we've talked to has said, like, yeah, if you had this plane here today, we would buy it, right? So the main thing I think that's incumbent on us to do is to execute and to build this plane, and you know, that's exactly what we're planning to do.
Right. We're still working on space-based ADS-B. I mean, the Ariane company. I don't know if ALPA has now a plaque on a satellite up there, an Iridium satellite, which is pretty cool. And we're big supporters of more dynamic management of the airspace. And some of the frustrations we share with AVORIA in terms of the delays sometimes with commercial space, where it's segregation, not integration truly. So we need to focus on what do we want this big picture to look like, this integration picture, because there's nothing be more frustrating for you to get in line with the rest of us, number 20 for landing, as we, go into a congested airspace and then try to find a spot get a slot in the runway and then get to a gate. So,
Nancy, any lessons learned that you picked up in terms of helping to facilitate this with, which in the work you've done with other new entrants?
Yeah, I mean, I think Joe hit on most of them, and which is essentially, and just to be frank, we have a lot of excitement about commercial space. I think everybody does personally, and even airlines have interest in that. But it has been largely approached in a stovepiped way. Whether you look at it in terms of the enabling statutes for commercial space, whether you look at it in terms of FAA's mandates for that, particularly with respect to the airspace, there should be integration among the commercial space elements for airspace access and basically for what is now subsonic airline travel. And there isn't a good connection there. And I think the industry's earnestly been trying to make those connections. And I say that with some of the unmanned aerial vehicle stuff has similar issues. I think something like supersonics will have an advantage because it would be something more akin, and it is very akin to what we fly anyway. And we're talking about similar airspace. We're talking about challenges that we are used to, different speeds and things like that. So there will still be significant issues. As I said before, I think airspace integration and management is one of the biggest ones that we'll see for the supersonics. But I think that the main things that I think we're glad that the manufacturers are working closely with on the business jet side with the business jet community, and on the airline side, Boom and others are working with us to talk about these concepts, unlike what we experienced in the early days of commercial space discussion, and to a degree, the unmanned aerial vehicles discussion.
Okay. In the last few minutes that we have, I want to switch over to a little different format, and I call it the lightning round. And by the way, I've got some questions I'm going to ask the panelists now. They haven't seen these questions, so it's going to be truly a off-the-cuff answers and give them a chance maybe to be a bit predictive in some of my questions. And so they can only answer in 1 or 2 words at the most, okay? So let's start with Joe. What one thing does industry and government need to do in the next 6 to 18 months to make supersonic travel a reality again?
Invest in infrastructure.
Infrastructure, okay.
Execute.
Pay attention to safety.
Okay.
Convince other parts of the world about the importance of the international standards, that moving those efficiently would be a good thing to do.
Okay. Here's a yes or no answer. Will we see supersonic commercial or business jets flights return to the market by 2025? Nancy, go first.
Supersonic flights by 2025? Yeah, I think we will. It's a matter of how much we'll see, but yes, I think that there certainly will, and there are timelines that could fit that.
I agree.
Yeah.
Yes.
I knew you'd say yes.
2 words? 2 words? Yes, if.
Okay.
Just got to put a couple pieces.
Okay, we'll start with Eli on this one and go that way and come back. What will come first, supersonic business jets or supersonic commercial jets?
I don't know.
Predict. Remember, your boss is sitting here.
Well, as Blake said, it doesn't matter who's first. It matters what matters, right? So we're not in a race with anybody, but I think they both have very similar schedules. So
Okay.
We'll see.
Business.
Business.
Yeah, I've been surprised they're neck and neck, but I would say business might just edge out the passenger jet.
Joe?
If I was a billionaire, I'd get one.
Okay. What or who is the biggest roadblock to bringing supersonic travel back to the marketplace? Chris? What's the biggest roadblock?
Oh, I thought you were saying it was Chris.
No.
I started earlier. We're trying to enable this thing. The public.
Okay. That's a good answer, Nancy.
Integration, environment, and airspace.
It's okay.
I got to change mine. I'll change mine.
Go ahead, Joe.
Success of, not the introduction, that would be the business model, I think, to make it commercially viable.
Okay. Eli? Biggest roadblock?
Engineering. We'll get there, but it's I mean, it's a real challenge. Yeah.
This again is really being predictive, at least from my perspective. You're going to be predictive. Which country is going to be the first to allow supersonic flights over land? Joe?
United Arab Emirates. They seem to be, you know, I'd say if you want some subsidized money, I'm sorry, I'm not going to get into the subsidized question here, but yeah, I think they'd be all over it.
Yeah.
So.
Australia, they actually said at the last Cape meeting, if we want to fly over the outback, you know, like Sydney to Perth, like we're welcome to do it. So.
Chris?
Yeah. I'm going to go with the boom guy.
Nancy?
You're
Yeah, I
enjoying
think
it.
so. I agree. I think they probably have fewer impediments to getting there.
Okay. That's what I would have said too, so it's good.
Get pitfalls.
What one thing do you think it's going to take, one thing, right, to create a sustainable commercial supersonic airline market?
Be able to check one free bag. I'm just, sorry, I just had to. Passenger revenue per available seat mile. Rather,
Economics.
it's got, you know, these are wonderful ideas, but there's a lot of great ideas. You just have to be economically viable, right? And safe, of course. Safe number one. They go hand in hand.
Eli?
Well, you can't do it without a plane, so that's what we're working on.
Okay, good answer. Yeah.
I'd say business case.
I agree with the business case, yeah.
Okay, and then the last one I have is in today's dollars. How much is that round trip ticket going to cost between Dulles and London Heathrow?
Can I start? Sure. I'm going to ask for the jump seat because I can get on there. I can go free.
You know, it'll be up to the airlines to price it, but we're designing it to be profitable for them at today's business class prices, so around $5,000 round trip.
I like that.
Yeah.
As the person who sits in the other side of the aircraft, as a government traveler, I would guess that that's probably going to be more than that, more than 5.
Okay.
But I'm not the business guy.
I don't have the data to confirm that it could be done on what it costs for a business class seat today, but I would say that it would not be done for that because we would still be flying aircraft with business class available on those same routes. And if they're going slower, they might be at a lower price than you would price something for a premium of speed. So I think I get the concept that you might have a return on investment with that, but I don't think that that's the way the market would work.
Okay, good.
Am I allowed to make one more pitch?
Sure.
Yeah?
Go ahead.
All right. You mentioned this, Blake, earlier in your thing about technology in the cockpit. I just want to point out, we've seen automation, right? We've seen some, I've seen in my years, automation change dramatically. Assistive technology that helps us do our job as well as humans, right? And then other ones that when they go awry. And I just want to tell you, if you imagine this is the acceptable level of risk, pilots love to be here. We are okay with here. We don't like being here. And sometimes, though, if you just look at what's going on in the world, we find ourselves out of here when the automation doesn't do what it's supposed to do. So until there's a level of artificial intelligence I'm not aware of, 2, experience, minimum of 2, experience, well-rested. Trained pilots are, You're the safest component on any aircraft, bar none. Just ask Sully.
Okay. We've got a couple minutes. Are there any more questions from the audience?
Okay. What's the biggest challenge area for certification of the supersonic, flight aircraft? And I'm also just curious, you're going to look at flying around 600. There's physiological challenges up there. Have we certified anything recently to fly up that high? I mean, I'm an Air Force guy, so I got to have oxygen mask, pressure suit, and all kinds of stuff. So just curious.
So I think that's part of the challenge. I mean, as you heard a number of times today, we're looking at many different facets of getting these aircraft into the sky safely. And I always kind of emphasize that piece of it. On the certification side of it, though, because of the composites, because of the cybersecurity aspects of some of the electronics that will go into these aircraft, I mean, it is literally going to be kind of hand in hand trying to work through the technological challenges as we look at it. We've become a much more performance-based organization. I would just put that out there. At the same time, no one's going to take a chance, whether it's 10 to the minus 6, 9, whatever. No one's going to take a chance, particularly on a new technology, not to slow it, but to enable it for success in the future. So I mean, whether it's composite materials, the electronics, there's just so many things that need to be tackled as we go along this path. Part of it, though, is to at least be able to have that conversation and generate the data that will inform those smart decisions before anything takes up into the sky.
Go ahead.
Follow up. This is okay. You're welcome. Thank you, Terry. What can an organization like RTCA, standards organization, do to help this journey?
I'll give you the $20 afterwards. Thanks.
So for me, okay, well, I would just say that, and you heard Terry in the opening today, the talent that this organization brings together to have these conversations, to set the standards, to inform decisions that the FAA will need to make isn't going away anytime soon. I mean, it's very valuable to the FAA to work together on these things, whether it's with the individual, the manufacturer, whether it's through a special committee. These are all things that kind of go into how we calculate what decisions we make. And so I don't see that changing anytime soon. If anything, I think it's going to increase as we look at some of these technological challenges. Quite honestly, the FAA is a fairly solid organization, but without the ability to always bring in the newest in terms of workforce. So we're going to rely on the technical experts out there in the field to help us inform what we're doing. And we just don't have the same types of, when you think of some of the other larger companies out there with the specialists in engineering, whether it's on the IT side of the house or the structural side of the house, we're going to rely on those folks. So I see the partnership with RTCA strong in the future.
I'll give you your $20 afterwards. Anyone else?
Sure. Just a little different question for Eli. What are the challenges with maintaining broadband communication at Mach 2.2?
The antennas and drag. So again, we're, when you're going at Mach 2.2, the air is like Jello, right? So it's, you don't want any more drag than necessary. So having something that's that won't add to drag and that can withstand the temperature requirements, because as Blake said, it gets up to 300 degrees, and you don't usually put the antennas on the leading edges, but still being able to withstand the rigors of the atmosphere and without contributing to fuel inefficiency, I think is the most important thing.
We're out of time. I'm sure the panelists will be available during our break. These are very important and very busy people, and I can't thank you all enough to take the time to be here. Nancy, Chris, Eli, Joe, just a real pleasure to have you here and engage in some good conversation on a very exciting technology. And again, thanks to Blake for his time and coming out here to Washington, D.C. and joining us. So thank you very much. It's a round of applause for our panel today.